Okay, looking at the board, we have 4 shapes. Okay, it's kind of a game here. You get 1 point for every right angle on your piece that you place on the board, 2 points for parallel sides, 3 points for the shortest perimeter. Okay, let's start with the triangle. How many right angles do we have? 1. So we get 1 point for that. 1 for right angle. Okay? Ooh, that's tough to see. Let's change the color there. Let's go pink. Will we see? No. Oh, no. Can't see pink.
What are you even doing?
I'm writing on the shapes. 1. All right. Oh, I'm paused. Jeez. Struggling this morning. There we go. 1. Okay, 1 for the right angle. How many parallel sides does that triangle have? None. So you get 0 points for that. And then the shortest piece on the board gets 3 points for being the shortest perimeter. So we got to find the perimeter of this triangle. What's the length of this bottom side? 3. On the side here, the right side, it's 1, 2, 3, 4, 5, 6, 7, 8. How do I find the hypotenuse? Pythagorean theorem. It's the right triangle. Pythagorean theorem. That's what we just learned last chapter. What's 3 squared? 9. What's 8 squared? 64. What's 8 plus 60 or 9 plus 64? 73. So what's the square root of 73 as a decimal? Oh, you need your calculators out today again, because you're going to use them today. So get your calculators out. About 8.5. Close enough. Okay? We can't mark which one has the shortest perimeter yet because we haven't measured them all. So let's go to the second one. What does this look like? A square. How many right angles do you see? So it gets 4 points for its right angles. How many parallel sides do you see? 2 sets. 1 set, 2 sets. So what's 2 plus 2? 4. So it gets 4 points for the 2 pairs of parallel sides. And then let's find the perimeter. Okay, how do we find the length of this side? Could use the distance formula, or could just make a right triangle here and find the hypotenuse, right? What's 3 squared? 9 plus 3 squared is 9. 9 plus 9 is 18. What's the square root of 18 as a decimal? 4.2. Thank you, Charisma. So if this side's 4.2, this side's 4.2, this side's 4.2, and this side's 4.2. Okay, let's go to, what kind of a shape is this? What's this called? Trapezoid. Okay, trapezoid. How many right angles do you see in it? None. 0 right angles. How many parallel sides? 1 pair of parallel sides, so it gets 2 points for that. And now let's find its perimeter. So this side has 4, this side is 6. If we go 3 and 1, 3 squared plus 1 squared is 9 plus 1, or the square root of 10. What's the square root of 10? 3 point what? 3 point what? 3.2. That sounds more like it. I thought you said 3.5 at the start, and I was going, what? Okay. And then this bottom shape is called a what? Parallelogram. Has 1, 2, 3, 4, 5, 6, 7 on the bottom. 7 on the top. The sides are 1 by 3. You go over a 1 and up 3, so it is 3.2, just like the trapezoid is. Okay, so 0 right angles in this, 1 set of parallel sides, and its perimeter is like 20.4. Is it going to win the perimeter battle being the shortest one? No, so that's not going to score. This perimeter is 10 plus 3.2 plus 3.2. This perimeter is 16.4. That might win. What's 4.2 plus 4.2 plus 4.2 plus 4.2? 16.8. That's not going to win the perimeter war. So that gets 0 for the perimeter. What's 8 plus 8.5 plus 3? 19.5. That's not going to win the perimeter war. So the triangle only scores 1 point. The square scores 8 points. This thing scores an extra 3, so it gets 5 points. And this one only scores 2 points, so the square wins. Okay? So, what hopefully you figured out there is ways to figure out lengths of sides by using the Pythagorean theorem as a shortcut to the distance formula. We don't need the distance formula. We don't absolutely have to have the distance formula because the distance formula is really the Pythagorean theorem in an expanded form. We can make it shorter, okay, by just looking at the Pythagorean theorem, just going side, side, figure out how far it goes this way, how far it goes this way, square both numbers, take the square root. So, in this one, how can you find the length of AB? Well, instead of using the distance formula, which is, I'll show you the distance formula again. It is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then you have to put the numbers in. Then you have to do the subtraction and all that. When it's almost faster, if we go, well, from 6 to 1 is 5. And from 1 to 3 is 2. What's 5 squared plus 2 squared? So it's the square root of 29, which is what as a decimal? 5.3. Okay? So using the Pythagorean theorem is going to be faster for us today than trying to use the distance formula. Okay, bisect. When you bisect something, you hit it at its what? Midpoint. And so today we're going to use the midpoint formula every once in a while. What the midpoint formula does is you add up the two x values, divide by 2, add up the two y values, divide by 2. Okay? So if we're doing it for AB, you add up the two x values, 1 plus 3, and divide them by 2. You add up the two y values, 6 plus 1, and divide them by 2. What's 1 plus 3? 4. Divided by 2 is? And then 6 plus 1 is? 7. Divided by 2 is? 3.5. Okay? Midpoint formula. Now, we're also going to look and see if we have right angles anywhere. So, it says, why do the slopes of AB and BC show that ABC is a right angle? Why is this a right angle? Well, we look at the slopes. And remember your slope formula. Slope equals rise over run. Or y2 minus y1 over x2 minus x1. But we're just going to look at rise over run. Okay? From A to B, we rise a negative 5, run to the right, how far? 2. So the slope of AB is a negative 5 because instead of going up, we go down 5 and to the right 2. For the slope of BC, what's our rise? How far do I go up from 1 to 3? 2. How far do I run to the right from 3 to 8? 5. So I rise 2, run to the right 5. Are these opposite reciprocals? Yes. If they multiply to be negative 1, they're opposite reciprocals. That means we have a right angle. And so we'll be checking for right angles on certain things. So here's a question that you might have. Okay? We want to find the length of this line that goes from here to here. Now, this point is a midpoint of side AC. This point is a midpoint of side BC. Okay? How long's MN? How long is that segment MN? Okay? Well, first we got to figure out what's the coordinates of MN. Okay? What's the coordinate of M? Well, if M is a midpoint of AC, what's 1 plus 8? 9 divided by 2, 4.5. Add up the two endpoints and divide them by 2. What's 6 plus 3? 9 divided by 2 is 4.5. So that point is at 4.5, 4.5. And if you look at this, yep, that makes sense. That looks about right. Okay? BC. BC. What's 3 plus 8? 11. What's 11 divided by 2? 5.5. What's 1 plus 3? 4 divided by 2 is 2. Looking at this, 5.52 looks like the right point. Now, how do we find the distance in between those two? Now, before we were using the Pythagorean theorem because it was easiest for us, but now, because we have all these decimals, I'd use the distance formula. The distance formula, you subtract the two x values. So you go 5.5 minus 4.5, and you square it. And then 2, the y value, subtract them, 2 minus 4.5, and you square that. So it's 1 squared plus negative 2.5 squared. Or 1 plus 2.5 squared is like 6.25. Just lay it on my desk. Thank you, Michael. And then, so it's the square root of 7.25, which is approximately how big? 2.7-ish. Okay. That's the length of that line. Okay. That's as hard as what we're going to do today. Okay. Everything else is basically, finding distances of triangles. Okay. All right. So if we want to find the perimeter, it's a right triangle here. So what is the difference between 2 and 5? 3. So we go over 3. What's the difference between 6 and 2? 4. What's 3 squared plus 4 squared? 9 plus 16 is? 25. Square root of 25 is 5. This side is 5. Okay. AC. We go up 1 and over 4. What's 1 squared? 1. What's 4 squared? So you take the square root of 17 on your calculator and you get 4 point. What? 4.1 about? Okay. And then from A to B, you go over 1 and up 5. 1 squared is 1. 5 squared is 25. So it's a square root of 26. So I bet that's 5.1, right? So 5.1 plus 4.1 plus 5 is like 14.2. Okay? Use the Pythagorean theorem or the distance formula, which is ever easier for you. Find the distances of each side. Is this equilateral, isosceles, or scalene? What does the word equilateral mean? All sides are the same. What does isosceles mean? Two sides are the same. What does scalene mean? No sides are the same. Now, do we even have to find the length of this side? We can tell that that's not going to be the same as the others. Is this one the same as this one? That's a big question. So let's see. From 1 to 5 is 4. From 2 to 8 is 6. What's 4 squared plus 6 squared? 4 squared plus 6 squared. 52, the square root of 52 is 7 point what? 7.2 about? Okay. On the bottom here, from 1 to 8 is 7. From 2 to 6 is 4. So it's 7 squared plus 4 squared. 65, the square root of 65 is like 8.1, 8.0, 8.1, somewhere in there. Are they the same? No. So it is scalene. Is this a right triangle? Okay. Do we find side lengths to figure out if it's a right triangle or not? Not really. I mean, we could, but it's faster to find the what of each side. Not the angle, the slope of each side. Because if we have opposite reciprocal slopes, then the sides form a right angle. Okay, what looks like the right angle, x, y, or z? Y looks to be the right angle, so let's find the slope of xy. My rise is 6, because I go from 2 to 8, so my rise is 6. My run to the right goes from 1 to 5. 1 to 5 is 4. 6 over 4 is 3 over 2. That's my slope. Now it's a positive slope because I'm going up from left to right. Okay, now y to z. I go down from 8 to 6, which is a -2. I go to the right from 5 to 8, which is 3, -2/3. What do we know about 3/2 and -2/3? Opposite reciprocals, which make this perpendicular. So yes, this is a right triangle. That's the types of problems you'll have today. Figuring out whether you have perpendicular lines or parallel lines and so on. Now, is this a parallelogram? Does this look like a parallelogram? Yeah. The slope of this is 3. The slope of this is 3. The slope of this, we go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So down 4 over 6, down 4 over 6. Yep, they're parallel. So it's a parallelogram. Now, is it a rhombus? Are all the sides congruent? No. So since we don't have 4 congruent sides, it's not a rhombus or a square. Is it a rectangle? Well, if we check the slopes, are those opposite reciprocals? No. So it is a parallelogram because it has opposite sides parallel, but it's not a square, not a rhombus, not a rectangle. Those are the types of things you'll do. Okay. What is special about a kite? Now, we only talked about a kite one day in here this year. So does anybody know what makes a kite a kite? It has 2 sets of what? Congruent sides. Yep, 2 sets of congruent sides. The congruent sides are next to each other. The opposite sides are not congruent. The congruent sides are next to each other. So let's see if the congruent sides are next to each other. How long is this? How long's PS? 4. How long's PQ? 4. So are they congruent sides? Yep. If we go up 1 and over 1, 2, 3, 4, 5, is that the same as going over 1 and up 1, 2, 3, 4, 5? Yep. Up 1 over 5 is the same as going over 1 up 5. It'll be the same distance. They'll both be the square root of 37. So these are congruent. These are congruent. What does it make? It makes a kite. To be a trapezoid, you have to have one pair of opposite sides parallel. You can see easily that there's no parallel sides here. So that's a kite. Ooh. Do we have one pair of opposite sides parallel here? Okay. We know that this is not a kite because there's no side next to this side that's congruent. So we know that that's not a kite right off the bat. But it could be a trapezoid if these 2 sides are parallel. If we go down 1 and over 2, if we go down 2 and over 3, are they parallel? Is down 1 over 2 the same as down 2 and over 3? No, they are not parallel. Are these sides going to be parallel? No. Can it be a trapezoid if there's no parallel sides? No. So it's neither. Okay, just looking at shapes, figuring out what they are. All right, Dylan, he's a chicken farmer, or he wants to be a chicken farmer, and he has 30 feet of fencing. Does he have enough fence to fence off this triangle there that he's going to make? He's going to put a post here, put a post here, put a post here, and string up wire to keep his chickens in. Okay? Does he have enough? Well, let's see. How far is it from 1012 to 102? How far is it from 1012 to 102? 10, because it's a vertical distance of 10. All right, from 26 to 1012, we go up by 8. No, we go up by 6. And we go over by 8, right? So what's 6 squared plus 8 squared? 36 plus 64. 100. What's square root of 100? 10. So this side is 10 as well. Ooh, this could be an equilateral triangle. Let's check. How far do we go down here? Oh, we only go down 4 here. And we go over 8. What's 4 squared? 16. What's 8 squared? 64. Square root of 80 is like 8.9. Okay. What's 10 plus 10 plus 8.9? 28.9. So is 28.9 less than 30? Yep. Does he have enough fenced enclosed yard? Yes, he does. Now, he's still on his chicken farm, and he has to figure out how many chickens he can actually have, because each chicken takes 8 square feet of space to be healthy. How many chickens can he have? Well, to find the area of a triangle is 1/2 the one side base times the height. Now, the easiest side to be the base is this side. And the height is a perpendicular distance from the vertex to that side. Well, that's this line right here. Now, how long is this line? Well, it goes from 2 to 10. How far is it from 2 to 10? 8. And we just said before, from 12 to 2 is 10. So if this is 10 and this is 8, we take 1/2 of 10 times 8. What is that? Half of 10 is 5. 5 times 8 is 40. Now, if each chicken needs 8 square feet of space and he has 40 square feet, how many chickens can he have? 5 chickens. He can have 5 chickens on his farm. Okay? All right. Just about done here. Okay? Here's 4 different roads. 1, 2, 3, 4. Okay? What's the length of all the roads? Well, the easiest length to find is D to C. How far is it from 3,8 to 9,8? How far is it from 3 to 9? 6. Okay? From 8,1 to 9,8, we go over 1 up 7. So it's 1 squared plus 7 squared, which is square root of 50, which is 7.1. From 1,2 to 8,1, you go over 7 and down 1. That's another 7,1, right? Well, 1 squared plus 7 squared is square root of 50, which is about 7.1. For this one, you go over 2 to get from 1 to 3. You go over 2 and up 6. 2 squared plus 6 squared is 4 plus 36. Square root of 40 is about 6 point what? 3. So 6.3 plus 7.1 plus 7.1 is 20.5 plus 6 is 26.5. That's the length of all the roads. So what we're doing is we use the distance formula, or for me, I like the Pythagorean theorem better. Okay, how far do you go over and down? Okay, but basically the distance formula, find lengths of size to classify figures like, is it scalene, equilateral, or isosceles. Use the slope formula to figure out whether sides are perpendicular, to figure out if it's a right triangle or not. And the midpoint formula to find a point that bisects. Okay? So you'll be doing these things in this section, just looking at shapes and figuring out various things about shape. Nothing too hard. Most of it is finding distances. And when it's laid out on a grid like that, it makes life really easy to find distances. So we get out at 9:05. That gives you just less than a half an hour to do this. With like at 9 o'clock, I'll hopefully hand out the tests and go over the tests with you that you took yesterday or last time.